Hello everyone and welcome to this video on Transformers, the revolutionary architecture powering ChatGPT, BERT, and modern AI in less than 10 minutes. You'll understand how they work, why they're so powerful, and how they've transformed artificial intelligence. Let's dive in. The four Transformers, recurrent neural networks, and long short-term memory networks dominated sequence processing. But they had fatal flaws. Sequential processing meant no parallelization. Information from distant words faded away. Training was painfully slow. Then, in 2017, Google's attention is all you need paper changed everything. Transformers process all positions in parallel. Long-range dependencies are trivial. Training became 100 times faster. The key innovation, attention mechanism. Let's see how it works. Self-attention is beautifully simple yet powerful. Consider this sentence. The animal didn't cross the street because it was tired. What does it refer to? Humans instantly know the animal, not the street. Self-attention lets models do this too. Every word simultaneously looks at every other word. It calculates relevance scores. The word it learns to attend strongly to animal and weakly to street. And crucially, all positions are processed in parallel, no sequential bottleneck. This is the revolutionary insight that changed AI. Attention uses three learned transformations: query, key, and value. Think of it like a database. Query asks, what am I looking for? Keys describe, what do I contain? Values hold the actual information. The formula is elegant. First, multiply query with all keys to get similarity scores. Second, scale by square root of dimension for numerical stability. Third, apply softmax to convert scores into probabilities. Fourth, multiply by values to get a weighted sum. High attention words contribute more, low attention words contribute less. This happens for every word simultaneously, making transformers incredibly efficient. Single attention is good, but multi-head attention is better. Why? Because one attention head captures one type of relationship. But language has many relationship types happening simultaneously. Different heads specialize. One might focus on syntax like subject-verb connections, another on semantic, a third on long-range dependencies, another on local context. Typically we use 8 to 16 heads in parallel. The process is elegant. Split the representation into H heads. Each head independently computes attention with its own QKV projections. Then concatenate all head outputs and apply a final linear projection to mix. Result: rich multi-perspective understanding that captures syntax, semantics, and structure simultaneously. This is why transformers work so well. The complete transformer architecture consists of two main components: the encoder and the decoder stacks. The encoder processes the input sequence. Each of its layers, typically 6, includes multi-head self-attention, which helps understand relationships between all words in the input. It also contains a feed-forward network for transformation, along with residual connections and layer normalization to ensure stable and efficient training. The decoder, on the other hand, generates the output sequence autoaggressively, one token at a time. Each decoder layer contains masked self-attention, so that predictions cannot peek at future tokens. It also includes encoder-decoder, or cross-attention, allowing the decoder to focus on relevant parts of the input sequence. Finally, a feed-forward network further processes these representations, again followed by residual connections and normalization. Positional encoding is added to preserve the order of words, and embeddings convert tokens into continuous vector representations. At the end, an output projection layer maps these vectors back into vocabulary space. This architecture is remarkably general, powering many systems. Modern transformers come in two main flavors: BERT and GPT. BERT uses only the encoder. It's bidirectional, seeing full context from both directions simultaneously, perfect for understanding tasks. Training masks 15 of words and predicts them from context. Invest for classification, question answering, and named entity recognition. GPT uses only the decoder. It's unidirectional. Processing left to right. Perfect for generation. Training is simple, predict the next word. This powers ChatGPT. Code completion and text generation. Both architectures scale beautifully to billions of parameters. GPT-3 has 175 billion parameters. GPT-4 is even larger. This scaling enables remarkable emergent capabilities. Transformers have transformed every domain of AI. In language, they power ChatGPT, machine translation, search understanding, and text summarization. In code, GitHub Copilot uses transformers for intelligent code completion. In computer vision, vision transformers classify images and DALL-E generates art. In science, AlphaFold solved the 50-year protein folding problem using transformer architecture. Audio processing, from speech recognition to music generation. Business applications from customer service to document understanding. The impact is profound. Transformers completely replaced recurrent neural networks as the dominant architecture for sequences. They enabled the ChatGPT revolution. Modern large language models. They have proven to be truly universal, excelling beyond just language to vision, audio, and scientific domains. We are living through the transformer revolution. You've gained a deep understanding of transformers. You know how self-attention works, letting every position attend to every other position simultaneously. You understand the query key-value mechanism that makes attention differentiable and learnable. You've seen why multi-head attention captures multiple relationship types in parallel. You know the complete encoder-decoder architecture with all its components. You understand how BERT and GPT differ and why both are powerful. And you've seen real-world applications transforming every industry. The transformer revolution continues. This architecture powers modern AI from chat to scientific breakthroughs. It's the foundation of the AI revolution we're experiencing today. Thank you for watching. You now understand transformers. Use this knowledge well.